Hello everyone, welcome to Java session. So in today's video, we're going to be talking about New Year's Day chaos. Yes. I'm not going to even explain why I came up with an algorithm that revolves around chaos, but then just know that I came up with an algorithm. Actually, I didn't come up with the question, I just came up with the algorithm to solve the question. So the question I actually got from HackerWank, just putting it out there. Another thing, I must state, I was speaking to someone who was the video I made about metrics, where the hourglass algorithm video, whereby I was showing you how to instantiate a two-dimensional array. You see what I'm telling you, what I actually did. So that was the issue. The person was like, I don't know how I'm going to implement the hourglass algorithm in real life. And then I actually explained to them that the videos that I do have nothing to do with the actual content. Like when I say New Year's chaos, I'm not saying that you're gonna have New Year's chaos one day and then you're going to have to implement this algorithm. No guys, just look at the method that I use to solve a problem and then try to reuse those methods in your own problem. See, so if you need that New Year chaos algorithm one, I actually showed you how to instantiate a two-dimensional array. You might need to do that one day. Maybe you need a grid, or you're just creating a two-dimensional game, or there's just a lot of things you're going to need a 2D array for. And also I showed you how to separate strings from string tokenizer. Say you are a backend developer and then someone just sends a weird JSON from their front end, and then you need to model it to actually fit in the description to add it into your database in your backend. And you need to know how to manipulate strings, to remove what's not needed, to add what's needed, to and that's the video actually showed you how to do those things. All you have to do is just think about how you're going to apply that algorithm in your real life. So in this video, it's about New Year's chaos. So the thing that revolves around it is that there's a line, and then everyone has a tag on the line. So in position 1, it has to be 1. In position 2, it has to be 2. But then we know as people, we don't we don't actually do like to be told what to do. So someone is being given 8 and then he's being told stay at 8. And then they'll decide to say, oh, 7, do you need some money? And 7 is like, okay, yeah, I do need some money. And then 8 is like, here's some money. But then here's another thing though, we do know who you are. We do know that you are number 8, and then we do know where you're supposed to be. And then when we see you in a position of 7, we know what happened. And then we need to tell the computer to know what happened. As humans, we already can tell that, okay, 8 is supposed to be here. Why is it here? That means he made 1 bribe. Why is it here? That means he made 2 bribes. Why is it here? Oh no, this is too chaotic. If we found a member here who made more than two bribes, and then we just cancel the entire thing, and then you just print out it's too chaotic. Let me scroll through this question so that you can go through it, and then after this I'm going to just code the solution, and then I'm going to explain the algorithm later. So I do recommend you to watch the video on slow motion if you wanna code along with me, because I'm going to make it fast. I'm not going to, the algorithm is pretty damn long, so explaining while typing will just make this whole tutorial video be like 25 minutes or so. So I'll just code the entire thing and then I'll explain it after coding it. So if you want to code along, then you can do that. If you don't, then I do advise you that you actually do look over this question, you pause this video, and then you try it yourself. Just try it yourself. And then if you, for some reason, you got the same answer that I did, but then you use a different algorithm, then please do let me know on the comments so we can discuss. So maybe I might learn something from you. You did something more effective, and then I'm like, oh yeah, this is effective. Or maybe you did something less effective, and then I might explain to you that no, if you do that, then see. So do pause the video and then try it for yourself. Let me just jump into coding right now.
Help your heart with your mind. Keep on chasing that dream. You better not run with it. 'Cause you're better than anyone. Live your dream. Dreams never fade away. Even if you look away, your altars don't look back. People tell you get it right. Dreams never fade away. Even if you look away, your altars don't look back. People tell you get it
Anyways, so as you can see here, I had to create a perfect queue in order to get an imperfect queue. Reason for this is because you can't know what is without knowing what isn't. Shit, okay. That made me sound philosophical, but in a sense it works like that. Like, you can't know, the computer can't tell what is an imperfect queue without knowing what a perfect queue is. Just as you as a person, you can't tell this is not a window without knowing what a window is. You can't tell that you can't tell people that I'm a good person without having an idea of what it means to be a bad person, right? So automatically, when you tell people you're a good person, you already told them also that you damn well know sure how to be a bad person, because you can't call yourself a good person if you don't know what it means to be a bad person. You know what I mean? And then, so that's how actually it works even with this algorithm. You can't know what is an imperfect queue without knowing what's a perfect queue. So as we communicate with the computer, communicate it the way we communicate with ourselves, obviously. Shit, I sound philosophical again. Is this coffee, guys? Is this coffee? But then what I'm implying by that, when I say we communicate with computers, that it's just try to think of it on yourself. How would you tell yourself that this is not a perfect queue? How would you know that that's not a perfect queue? First, you need to know what a perfect queue is, right? You need to know what a 1 is in order to determine that's not a 1. So also I did the same thing with a computer. There was a different method, but then I thought this one was a bit educational and also efficient, because it also teaches you that you can't really know what is without knowing what isn't. So I also told you that you can't know what's an imperfect queue without knowing what's a perfect queue. So I made a perfect queue, and then all from there it was all a matter of comparison and telling your computer what to do in case this happens. So like here, I check first before I actually go and calculate the swaps, the bribes or swaps or whatever you want to call them. I first check, is there chaos? In order to check chaos, like they stated here on the question, where's that part? The minimum. There's a part where they stated that the minimum is true. Damn it. Oh yeah, here it is. It requires a person to have bribed more than 2 people. Then the state is invalid. In order to print out these 2 chaotic, then it happens good to someone bribed more than 2 people. We have a psychopath now in the line. Like, how? Okay, you bribe 1 person. Okay, we see you're a bad person. You bribe 2 people. Oh damn! No, you're bad, bro. Why would you bribe 2 people? Now 3. Now 3. Now we just break out the algorithm. It's too chaotic, man. 3 people. We bribe 3 people. Now if it's more than 2, we just say too chaotic. Like here, for example, if you can see in this line, number 5 actually bribed 3 people. Number 5, if he bribed 1 person, he would be here. Number 5, if he bribed 2 people, he would be here. Now he's here. It means that he bribed 3 people. So that's what I did here. I checked first if there's chaos, and the same way I explained to you, I actually solved it the exact that way. Is number 5 at number at 4, meaning it bribed 1? No. Is it at 3, meaning it bribed 2? No. Then there's chaos. If it's not a 2 and 1, then there's chaos. You can't bribe more than 2 people. And then after finding out that there's chaos, then I just give the answer it's chaos, and then I break the loop. I don't need to check anything more, because also for speed I could go over and over, and then maybe, I don't know, have an away that will add 3, and then at the end of the loop I check if that away contains a 3. If it contains a 3, then I print out these 2 chaotic. If it doesn't, then I print out. But then that's a lot of waste. I am like, whenever you're coding, guys, always think about speed. Speed is everything. Your clients don't give a damn about how sophisticated your algorithm is. All they care about is that your app is going to finish in time or not. Now the app is supposed to print out 2 chaotic, someone print out 3 people. Now if you find out someone prep 3 people, why do we need to check others? Because the whole point is someone, not how many people did it. Did someone do it? So we found out someone did it. Now we're like, okay, we found someone did it, so it's security. And then also same here, if it didn't bribe more than two people, and then also it didn't bribe one person, that means it bribed two people logically, right? And then if it bribed one person, then also here we're just checking if it bribed one person, then else is just confirming our logic towards this whole thing. And then I keep on giving answer minimum swaps. I don't increment it because strings are weird in Java. I don't want to because strings are weird everywhere in Java, Python. Strings are just weird things. So yeah, that's how I do this thing. And also here's a new method of swapping that I think maybe I should let you guys know about. So how it works is simply by saying say for example we have 4 and 3, right? And then we want to put 4 in a position of 3. How do we make 4 3? In order to make 4 3, we have to say the addition of 4 and 3 minus 3. You feel me? So it's like say you have let me do this. Say you have num1 being 4, num2 being 3. First of all, I'm going to need to destroy. The whole concept of in order to make, you have to destroy a thing, but then it has to be a controlled destruction, controlled chaos. In order to create, you need to create a controlled chaos. That's what I did. I created a controlled chaos. I destroyed 1 first. Okay, 1 will be the sacrifice. 1. Okay, I'm going to destroy you, and by destroying you, you are no longer 4 now. I'm going to make you 7. Damn, 1 is 7. But then 3 remembers. 3 ones has something in common with 4. They all want to change places. So now 3 is like, okay, so you put me inside you in order to make you. Now how will I make me you? That means I have to remove me outside of you. Now 1 made himself 7 by putting number 2 inside of it. Number 2 will make itself number 1 by getting out number 1, by getting out itself outside of the new number 1. So that means in order to fix chaos that is controlled, everyone should work together. So in that way, in order to get number 2, we have to remove number 2. So just as well as 1 has to destroy itself, 2 has to fix 1 by destroying itself also by saying num1 minus 3. Remember now num1 is 7, right? Num1 is 7. Now what is 7 minus 3? It's 4. Now number 2 is already 1 now, see? So it's all about the philosophy of destruction in order to create. And then number 1, you do the same thing. Number 1, you have to remove number 1 from the new number 2. So you can see now we all had our desired output because everyone worked together. Number 1 and number 2 had to work together in order to get the same desired output. That's the entire philosophy behind this algorithm, guys. So yeah, that's how everything works. Please do subscribe if you're new, leave a like. Also don't forget to follow my Instagram. Like this subscription, they actually do motivate me a lot. Like I just got a subscription 2 days ago, and I was like, what? So people are still watching? And then I made another video. So like this subscription do help me a lot. So please do subscribe. If you know your friend is interested in programming, let them know to subscribe. Like your cousins, AMG die. I don't know, Poma, but just subscribe, dog. Just subscribe. Anyways, this is how you do the chaos swapping algorithm. You learned a lot here, how to swap, how to sort. You actually even learned, because after all, this thing is going to sort out that algorithm, the lane. So you also know how to sort integers, sort using quick sort. See, don't look at the newest chaos, look at the method I used to solve the newest chaos. Goodbye, everyone.
Help your heart.